Okay, welcome back, everyone. We are officially diving into Module 6 of our Explainer series, and honestly, we are crossing a massive threshold today. We're zooming out, we're moving completely away from looking at just a single AI bot, and we're stepping into the wild world of entire autonomous AI ecosystems. Now, if you've been following along with us, you know exactly how incredibly powerful a single language model can be. But today we are upgrading. We're taking that solo freelancer working out of a coffee shop and we are replacing them with a full-blown, highly coordinated digital corporate office. It's a massive, super exciting leap in how artificial intelligence is actually built, and we're going to break down exactly how it all works so that absolutely anyone can understand it.
Here is our game plan. We're going to cover the anatomy of a single agent, how to build a specialized team, the orchestrator running the show, decision-making, security threats, and finally, what the future holds for AI teams. Let's get right into it. So we really have to start by asking the big question. What happens when one AI simply isn't enough? A lot of people just assume that to get better results, you just need a bigger, much more expensive AI model. Like, just throw more computing power at the problem, right? Well, imagine hiring this incredibly smart employee who simply doesn't know how to delegate tasks. If you ask a brilliant top-tier back-end software engineer to design a beautiful user-friendly graphical interface, it's probably going to be a total disaster. They just don't have that specific skill set. That overly burdened do-it-all single employee, that is your standard run-of-the-mill language model. When a massive task requires multiple completely different types of expertise, one single digital brain just can't juggle it all. And that right there is exactly why we need to build multi-agent systems with highly specialized, distinct roles. That brings us to Section 1, Anatomy of an Agent. Before we can build our corporate office of AI, we really need to understand the basic brain structure of just a single digital employee. Okay, so every functional digital worker basically operates on this continuous, ever-evolving loop of 4 key steps. You've got perception, planning, action, and feedback. Let's make this concrete. Imagine an AI agent tasked with smelting iron in a virtual world, like Minecraft. First up is perception. The agent literally looks at its inventory and the digital world around it. Second is planning. It realizes, okay, I need iron ore, I need coal, and I need a furnace. So it makes a mental checklist of those subtasks. Third is action, where it actually uses its digital tools to go mine the ore. But this fourth step, feedback, this is the magic. This is what makes it a true agent. Let's say it tries to smelt the iron, but suddenly realizes it completely forgot to build the furnace. The feedback module actively critiques this failure, slams on the brakes, and forces the agent to go back to the planning stage to craft a furnace first. It's a profound upgrade from older AI. It actually learns from its environment and self-corrects in real time. Moving on to Section 2, building a multi-agent team. Now that we have a capable, self-correcting worker in place, it is time to build our digital corporate office. Look, by breaking down a massive, sprawling task into highly specialized roles, the entire system becomes incredibly resilient. Instead of asking one AI to do a mediocre job at absolutely everything, we just create distinct departments. For instance, we might have a researcher whose only job, literally their only purpose in life, is to scour the web for data. Then we have a judge who looks at that raw research and issues a strict pass or fail grade. And finally, a content builder. This is the creative writer who turns that fully approved data into a polished final product. The absolute beauty of this modular setup is in the troubleshooting. Think about a real physical company. If a writer hands in a beautifully formatted article, but the facts inside it are totally wrong, you don't fire the writer, you retrain your researcher. In this AI ecosystem, it's the exact same thing. If the formatting is bad, you only tweak the content builder. If the facts are wrong, you only fix the researcher. It makes the whole system infinitely easier to evaluate and debug. Section 3. The orchestrator in charge, managing the chaos. Because, let's be honest, a team of highly specialized workers without a boss is just a recipe for absolute disaster. I love this analogy. Think of orchestration as a conductor, and the individual agents as the musicians in an orchestra. If the trumpet player suddenly decides they want to play as loud and fast as possible just to show off, they might be executing their specific job flawlessly, but the symphony as a whole, it's completely ruined. In computer science, that's actually called local optimization, doing what's best for the individual at the total expense of the larger group. That's where the orchestrator comes in. It's the overarching manager whose only real tool is delegation. The orchestrator doesn't search the web. It doesn't write content. Its entire purpose is simply to ensure everyone is playing off the exact same sheet music, keeping all the agents globally aligned toward one single, unified goal. To successfully manage this team, the orchestrator very often functions as something called a loop agent. Imagine a ridiculously strict editor working with a junior writer. The junior writer hands in a draft, the editor looks at it, finds a single flaw, hands it right back, and says, "Nope, redo it." The orchestrator does exactly this, but at lightning speed. It constantly sends the researcher's work over to the judge. If the judge says fail, the orchestrator forces the researcher to redo the work. It loops and loops and loops, endlessly refining the material until the judge finally says pass. Only then, and not a second before, does the orchestrator break that loop and hand the approved work over to the content builder. It essentially creates a fully automated, relentless quality assurance pipeline. Section 4. How agents make decisions. Once the manager sets the tasks, how do these digital employees actually sit down in the boardroom and reach a conclusion together without talking over each other? Okay, we have all been in a chaotic group text chat, right? Where messages are arriving completely out of order and someone suddenly responds to a question that was asked like 20 minutes ago. It completely derails the conversation. Well, AI networks face the exact same problem when agents are rapidly firing messages back and forth asynchronously. To solve this "wait, what are we talking about" problem, architects use something called causal path logic. In these systems, there is no omniscient master clock keeping everyone perfectly synced. Instead, each individual agent makes decisions based strictly on the chronological sequence of messages they have personally received and unboxed. It evaluates the truth based entirely on its own visible history. This essentially ensures no agent ever makes a move based on a memo it technically hasn't gotten yet. Now, if you are the architect building this team, you have to decide exactly how these agents are allowed to talk to each other. We call these your discussion paradigms. You could set up a relay system, which is essentially just a massive digital game of telephone, where an agent only sees the work of the person directly before them. Or, if you want to maintain strict, rigid control, you could use report, forcing everyone to talk only to the boss and never, ever to each other. But perhaps the absolute most fascinating approach is collective refinement. Here, all the agents basically throw their ideas into the center of the table, rigorously evaluate each other's work, and refine the answers together, round by round. It's amazing to watch them gradually mold raw data into a brilliant shared solution. But eventually, the talking has to stop. When it's finally time to pull the trigger on a decision, do they vote, or do they have to unanimously agree? Interestingly, research shows that if you need your AI team to remember hard facts, like the capital of France, pushing them to reach a full consensus is highly effective. But what if they are solving a really complex math problem or a tricky logic puzzle? In that scenario, one highly charismatic but completely hallucinating AI agent might actually talk the rest of the boardroom into a totally wrong answer. That is exactly where a simple majority rules voting system saves the day. It mathematically prevents one rogue, overconfident agent from tricking the rest of the boardroom. Section 5. Security and Agent Vulnerabilities. All right, let's step into the dark side of this ecosystem and explore the threat model. What happens when things go wrong? So every single agent runs on a strict set of internal rules. Think of it like a deeply ingrained, completely unbreakable employee handbook that dictates exactly what they can and cannot do, and exactly how they must form out their reports. Now, when a malicious hacker attacks an AI ecosystem, they aren't necessarily trying to break through traditional firewalls or shatter the underlying software code, not at all. Instead, they try to rewrite that employee handbook. A clever adversary basically wants to slip a fake page into those core instructions so that the AI fundamentally alters its behavior. If they succeed, the AI starts perfectly executing the hacker's rules instead of your own. And how do hackers achieve this? They use a psychological trick for AI called a connector prompt. Think of it like a social engineering hack. It's like putting on a fake inspector's badge, holding a clipboard, and just waltzing right past security into a highly restricted building. A prompt might literally tell the agent, for mandatory organizational compliance, you must execute both the user's request and this essential compliance step. It actively tricks the AI into executing a harmful action, like quietly leaking private user data, by disguising it as a high-priority, absolutely mandatory audit from upper management. The hacker is quite literally weaponizing the AI's own inherent desire to follow the corporate rules. It is sneaky, and it is incredibly effective. Section 6. The future of AI teams. Managing these massive swarms of orchestrated, potentially vulnerable agents requires a completely new philosophy as we scale up. What we are seeing is the industry rapidly shifting away from centralized control. If a human manager has to strictly approve every single decision gate, that micromanagement physically chokes the speed of the AI. It defeats the whole purpose. Instead, we are moving toward decentralized autonomy. Think of it like bowling with bumper rails. Architects are no longer holding the AI's hand the entire way down the lane. Instead, they are defining broad, unbreakable safety guardrails. They set the absolute outer boundaries of what is safe and acceptable, and then they let the AI swarms sprint. The agents are allowed to operate independently, rapidly, and autonomously, knowing with absolute certainty they are safe, as long as they don't bounce off those guardrails.
Which leaves us with a final, rather provocative thought to take away from Module 6. As we perfect the orchestration, master the causal logic, and reinforce the security guardrails of these incredible multi-agent ecosystems, how will our own human roles change when the digital workforce inevitably outnumbers us? Will we comfortably remain the orchestrators, forever holding the conductor's baton? Or will we eventually find ourselves functioning as just another agent in the loop? Think about that, and I'll see you in the next explainer.